Hello guys, welcome back to Math Zone African Motives. We are still on our mathematics N6, and this is differential equations. From the question paper of November 2022 exam, we are going to see how we are supposed to attempt these typical questions on question 4, 4.1, and also 4.2. So the first part of our equation here, which is on 4.1, we are asked to determine the general solution of this equation. All right, so we've got 4.1, that is t minus 1 to the exponent of 3 ds dt, all right, plus 4 into t minus 1 to the exponent of 2s is equal to t plus 1. So this is what you're given. And we are asked in this case to determine the general solution. All right, the first thing that you're supposed to realize is we are working with a first order linear, that is a first order linear differential equation, which we know if it was to be written in terms of x, it was supposed to be written as dy dx. Let's say it was written in terms of x. It was supposed to be dy dx plus py is equal to q. All right, where P and Q are functions of x. These must be functions of x because we are talking about x. But this time, we are not having x in this case. We are having s with respect to t. So meaning to say we are going to have this as the derivative of s with respect to t plus p times y. The y that we have here was for y dy dx, but now it's ds. So meaning to say this is represents not y but s this time. Okay, we are talking about s. So this is for s. So it's gonna be ps. This part here, ps, where this p and q, they are no longer functions. They are no longer functions of x, but they are now functions of what? Of t. They are representing the functions of t, what t is representing. So p and q, they are functions of t this time. These are functions of t. So we are supposed to have our first order linear differential equation in this format, right? The s dt as a linear. So what is it that we are supposed to do to remain here with the s dt? What is it that we are supposed to do? It means we are supposed to remove this t minus 1 to the exponent of 3. That is what we are supposed to do. So we are supposed to remove this. How? By dividing by it throughout. Because we need to remain with the s dt plus ps. This is the format that you're supposed to have as long you are working with what? The first order. Okay, I hope we are together there. So we are going to divide by t minus 1 to the exponent of 3 here, t minus 1 to the exponent of 3 here, also t minus 1 to the exponent of 3. Each and every part of the equation, remember it's an equation, whatever that you affect is supposed to affect each and everything, right? So if we do this, it means we are going to cancel. And also, all right, I wanted us to have this. Let me also explain this way. I want you to understand me, guys. I want you to understand me. I want you to see this part also before we solve. All right, I want us to go back to the formula sheet so that we explain some of the other things that you are supposed to also understand. In your formula sheet, this part that I was explaining is this one. This is for a linear, all right? Whenever you are working with a linear, this is the format that you're given. Dy dx plus py is equal to what? To q. So therefore, you shall have your integral in this format here. I shall explain this format. This is how you work out a linear, all right? So like I said, it was in terms, if it was in terms of x, now it's in terms of in terms of t. So that's why we have this as ds like this in this format. Okay. Anyways, let us solve. I'm going to explain that formula later on. So here, if we divide, we're going to cancel. That means we remain with ds dt. So this is going to be ds dt. So if we divide here, if we check here, there are two of them, t minus 1 squared, t minus 1, here there are three of them. So if we cancel, it means here we're going to remain with one of the t minus 1. Okay, so that will be 4. So take note, the format here is supposed to be ps, where p is a function of what? Of t. So meaning to say this, we are going to write as 4 over t minus 1 like this, so that we properly see this as, we are supposed to see this as here. So that will be as like this, okay, which is equal to q represents a function of t. So this is what we have on this side, and this cannot be simplified. So we're just going to leave it as it is, t plus 1 over t minus 1 to the exponent of 3. This is our q. So this is what we have, ds dt plus, so this part here represents what? Your p. And this whole part here represents your what? Your q. That is what it means. Okay, so how do you solve from there? That is the question. How now are you going to solve from there? So if we check now, I want us to talk about that formula now. I want us to go back to our formula sheet and explain, so that guys, we are doing revision. We talked about this, but let us just do our revision. So here we are given that if we can have our format in this way, like this way that we have here, we are going to determine, if you check here, this is y, which was part of our function as it was before, all right? Q, which was part of our function as it was before. The only thing that we are not seeing here is the p. The p that we have, it's now affected here on, this is the one that is, we see here, which is e to the exponent of the integral of p with respect to x. What does that part mean? This part, it represents what is called the integral factor. The integral factor. Okay, let me write it down. I'm going to write that formula. Once you are working with a linear, that is the formula that you're supposed to take for a linear. So it states that, all right, from our formula sheet, that was y there. Remember, y, every part where there is y is now s. So it is going to be s. So our formula is supposed to be, let me write it even here, s, all right, e to the exponent of the integral of p with respect to x. But are we talking about x now? We are talking about t. So it's going to be with respect to t, okay, is equal to the integral of q. We still have our q as it is, which is fine, times e to the exponent of the integral of p with respect to what? With respect to t, like I said before. And this again is with respect to t, not with respect to x. If it was a function of x, you're going to use with respect to x. So like I said, all right, this is what I wanted to explain. This part here, the e to the exponent of the integral of p with this one is called the integral factor. So it is something that you're supposed to calculate on its own. So it is taken from p, from this p here, from this p here. All right, that's where you are taking your integral, this p, and our p. In actual sense, we are working with the sign. In this case here, I just circled for we are supposed to work with the sign, which is the positive also. So we are supposed to have our integral factor, which is the part of e to the integral of p with respect to what? With respect to t this time, which is we are supposed to find first the integral of this, then we put it this way. All right, we put it on our formula. So what is the integral of p? What is representing p? P is represented by this part here. So we need the integral of this. So what is the integral? Let us just calculate our integral aside. The integral of p, which is 4 over t minus 1 like this with respect to t. That is what p did, this one. That is what it means. So we were actually supposed to write it like this, but I just want us to have this aside. We're supposed to write it as e to the exponent of the integral of p, which is this part, our p here. Remember, that's our p. So you're supposed to write it as 4 over t minus 1 with respect to t. But I'm saying this integral here, just do it aside, okay? This is the one that we have here. So how do we integrate this? All right, we can take the 4 out. So that will be 4 over 4, the integral of 1 over t minus 1 with respect to t. Remember, I talked about this in from our partial fractions, all right? In our partial fractions, so this gives us a ln. So it's going to be 4, the ln of t minus 1. And as you can check the derivative of a t, there it's a 1. So it does not affect. But if it was maybe 2t or 3, you divide by that number. But in this case, there is a 1. So if we divide by 1, 4 divided by 1, it remains as it is. So it's going to be 4 ln t minus 1. All right, then we've got the constant of integration, which is fine. Just leave it like that. So this is what we have here as our integral. So it means here we are going to have as e to the exponent. We got the integral of this part here. We integrated here. We got 4 ln t minus 1 like this, plus the cost of integration. Don't worry about that. Don't write that constant. All right. But now, because guys, like I said, N6, it's back to N1, N1. Remember in our N1, I think it was N1 or N2, yeah, it was supposed to be N2, where we explained that e to the exponent of a ln x like this is equal to x. Okay, do you still remember this? Okay, no problem. We are supposed to understand that. So let me put it this way. I want us to have a recatch. This is what I'm trying to explain here. If we have e like this to the exponent of a ln, let us say ln 2 like this, our answer is supposed to be 2, which is this number here that is on ln. Our answer is, if we put a 7 here, our answer is going to be a 7. Are we together, guys? So this is something that you are supposed to get in mind again once you work with a ln like this. So we are saying it must be a ln x, a ln of a function, but this one, there is a 4 which is affecting our ln. So we are supposed to take it so that it becomes a single ln, a single term, not to have this 4 outside. So how do you take this 4? Remember, from our laws of logarithms, 4 can be raised to be the exponent. So it's going to be ln of t minus 1 to the exponent of 4. That is the number multiplying a log can be raised to be the exponent of a log. All right, now we can apply this law. This is the one that I want us to apply now. E to the exponent of ln x gives us x. So it means e to the exponent of ln this function, our answer is going to be that function here that is representing what? That is representing our x. So meaning to say this whole part is going to remain as t minus 1 to the exponent of 4. So this is the law that we are using. So if it is e to the exponent of ln a, our answer is going to be a. If it is e to the exponent of ln, maybe it's x squared like that, our answer is going to be also x squared. We take that part that as it is. So we're just taking what from this law that we have. So that is how we are supposed to have this. So meaning to say, this is our integral factor. From that e that we had, the integral of this, we simplified. Now we just ended up with a single term like that. That is what we just have now as our integral factor. So wherever there was an e to the exponent of this, we are going to present, or we are going to replace with this. That is where that formula plays a role, this formula here. So we are now substituting into the formula. We are saying s, in this case, our formula states that it's going to be s, which if it was dy dx, it was going to be y. But this one, it is the s dt. That's why we are using s here. So if it was dy dx, we were supposed to use y here, okay? So s, there's nothing to substitute for s. It's just s as it is as a function. So this is s times the integral factor now, this one, all right, which is e to the, this is the one that we were simplifying all along here, the e to the x, we got this. So we got as t minus 1 to the exponent of 4. So it means wherever we see this e to the exponent, we are going to substitute with t minus 1 to the exponent of 4. which is equal to the integral of q. What is q? Q is this function that we have on the right-hand side from the format that we have q, this one. And we say this is our q, which is t plus 1 over t minus 1 to the exponent of 3. All right, times the integral factor. This e is the same as this e that we have, which is our integral. So we're going to substitute again our integral factor, t minus 1 to the exponent of what? To the exponent of 4 with respect to what? To t, because we have everything here is of t. So we are going to integrate that with respect to t. So that is the role of the integral factor. Once you have this, we are done. You substitute into the formula. So you have 1, the format, you have it in your formula sheet. 2, the format on how to simplify it is there in your formula. So it's just a simplification that is straightforward. All right. So now we have to simplify. Remember, we are supposed to determine the general solution. So the general solution, you just integrate, you leave it like that. All right. Particular solution, that's where you substitute, remember, from our differential equation in N5. Where they ask a particular solution, you have to substitute the given values. So here we are supposed to integrate on them, on this integral, because we still have the integral sign here. All right. So on the left-hand side, there's nothing to be done. Just gonna rewrite as it is, t minus 1 to the exponent of a 4 times, you can even write s here, like this. You can even write s here, which is fine. All right. Or you can write s at this part, which is one and the same thing. Okay. This is equal to, all right, we can simplify it. As you can see, this is same as over 1. So we've got these brackets are the same, so you can simplify. There are 3 of them. If we divide into these ones, which are 4 of them, we are going to remain with t minus 1 there. So meaning to say, we are going to obtain the integral of t plus 1, t minus 1. It's a difference of 2 squares. If we check properly, this one, t minus 1, and t plus 1, that's a difference of 2 squares, which was taken from what? T squared minus 1. Or you can expand your brackets properly, t plus 1 into the bracket of t minus 1. You expand, still we are going to get the same thing. Or just see the difference of 2 squares from t squared minus 1 squared, which gives us 2 of these brackets. All right. So now we can integrate. So it's going to be t minus 1 to the exponent of 4 times s is equal to, we have to integrate each part. So if we integrate, remember integration, we just have to add 1 on the exponent. So that will be t. If we add 1 here, that will be t to the exponent of what? Of 3. T to the exponent of 3, we divide by the new exponent that you have now. All right, 1 with respect to t is going to give us what? Minus t. So that one is going to give us a minus t, all right, plus the constant of integration. So that is for the general solution. We are done. We leave it at with the constant of what? With the constant of integration. So that's how you play around with this type of an integral from the linear. We have the format first from the p that we have, which is multiplying as ps, this one, this p. You determine the integral factor of it, which is e to the exponent of what? E to the exponent of the integral of p with respect to determining. Now it is determined, like if it is what with respect to x, you use x. If it is with respect to t like this, you are going to use what? With respect to t. By finding the integral factor, which is e to the exponent, we are just substituting now into the formula. Wherever there is e to the exponent of the integral of p, whatever that you have there, you are now substituting with the answer that you got. But make sure that you simplify your integral factor in simplest form, because if you leave it like at this stage, maybe you do not know that this can be simplified further into this. It means you'll be stuck and there is no way you're going to simplify if you do not know that law. So that's why I say, guys, let us also find some time to revise our N3 stuff. Just the laws, don't go deep, just like, because already you covered N3. It's like just to recap your laws of logarithms, exponents, and this and that. It's not like we are going to have everything deep into. No. It's just a basic. All right. So let's check the other question that we are given, which is 4.2. So in 4.2, if we check 4.2, we have another part again to solve, which is this one is now the second order. All right, so you're given a second order there whereby we got, okay, let me just rewrite this down so that we do understand. So that is the second derivative with respect to t, of s with respect to t, plus 4 ds dt. So you're supposed to also consider the type of an equation that you're given there. All right, plus 13s is equal to 39t squared plus 11t plus 54, like that. Okay, so there we need the particular solution. That's why we are given this information here. Remember, from our N5, we also had a condition where you determine the particular solution and you'll be given a certain information to use. So what we have, if we are dealing with a second order, a differential equation, we were supposed to have our general format. If it was in terms of x, because we are used to that x, it was supposed to be like this: a or dy, which is the second derivative, right, plus b dy dx plus cy is equal to f of x. That was supposed to be our format in a normal part. But this time we are given s. So it is still the same thing. As we can see, we still have our quadratic part that we have, and also the f of t in this case, which is representing f of what? F of x. So what you're going to do in order for you to solve this, you're supposed to formulate what is referred to as the auxiliary equation. So you're supposed to form your auxiliary equation in this case. And the conditions that you're supposed to use, remember our conditions for the auxiliary equations are the first, the s dt, which is supposed to be, if it was dy dx, that part of dy dx will be equal to r. So you're going to let r to be equal to ds dt, representing dy dx, okay? Then s at that moment, this part of s here, which is representing y, wherever there's s, so this s is for y. Y was supposed to be equal to 1, so s is supposed to be equal to 1. Then this f of t, which was supposed to be f of x, we know that f of x is supposed to be equal to 0 at that moment. So it means f of t must be equal to 0. So this is what we have. So if r represents the s dt, therefore it means here we are going to have r squared. This is a squared, so you're going to have r squared plus 4 times the s dt. Our s dt is represented by r. Then we said s must be equal to 1. So this is 1 times 13, which is 13, is equal to the whole of f of t. This one is the function of t. This whole part here must be equal to what? Must be equal to 0. So what you do is that you are going to solve your auxiliary equation, all right? By having this, you are going to solve for r. So this is a quadratic and we do not have factors 13. We cannot have factors of 13 that we can add to give us a 4. So there we do not have factors. So the only thing that you can opt is for the quadratic formula. Remember, x is equal to, now it's r is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. All right, so remember our quadratic formula. So that means here we're gonna just substitute, okay, because sometimes it can be a normal quadratic, sometimes it can be a complex, which gives us complex solutions. So what you're going to do is that it's better for you to substitute properly, all right? So it's better for you to substitute properly. R is equal to minus b, which is minus 4 plus or minus the square root of b squared, which is 4 squared, minus 4 times a, which is 1 here, times c, which is 13 over 2a. So this is over 2a, which is 2 times 1. So like I said, we are supposed to properly substitute our information because it can be a negative under the square root, which is, you are talking about a complex solution. So on that condition, you might find it difficult if you just substitute, because the calculator will give you maths error. Then you wonder, why is the calculator giving you maths error. So simplify this part under the square root first. 4 squared minus 4 times 13 like this, 1 times 13, this one, you are going to get a negative 36. So what does this negative mean? It means we can't determine the square root of that number. Remember, the square root of a negative cannot be determined. So we can't determine the square root of what? This negative 36. So it's a complex. This is a complex number that we have. So that's why I was saying you have to be careful. So this is minus 4 plus or minus what is going to be the square root of a negative, because it was supposed to be square root of 36. We know that the square root of a negative is I in our complex. This is going to be I. Then the square root of 36, which is 6. So the square root of 36, that will be a 6. So this will be I6, or you can use a J in that case. All right, over 2. So the reason why I'm using R here, because some of you might be wondering, why am I using R instead of M? Then here, why am I using I instead of a J? This is what we have. If you check on your formula sheet for the second order, these are the formats that you are going to have at the end from the equations, from this auxiliary equation. If you check here, these are the solutions that you are given here. Your solution, maybe they are not the same. They are saying R1 is not equal to R2. These are solutions. So as you can see, for you to have solutions, it means it was given as AR squared plus BR plus C is equal to 0. It was in terms of R. That is why our solutions here, they are saying R, but you can use M as long as you know that M represent or is the same as this R here. So it can be on a condition where these solutions are the same. R1 is equal to R2, or it can be a condition where R is equal to A plus or minus IB. What is this format? This is the format of a complex. When we do not have real solutions, the solutions are not real for a complex. The square root of a negative, remember, it's I. And this is the one that we are talking about now. So yes, so that is why I'm saying we are going to use this I, but you could have used J, but I just want us to be familiar to the formula sheet also. All right. So this here, if we solve, it is going to be R is equal to, so you're going to divide 2 is going to be separated here into minus 4. So minus 4 divided by 2, that will be minus 2 plus or minus I, 6 divided by 2, which is going to be a 3. All right, so this is our R in this case, representing the solutions that we obtained from what? From our auxiliary equation. So depending on the solution, on the solutions that we had there, we are going to write what we refer to as the equation for the complementary function. Okay. I just hope I'm not confusing you now. I want to move stage by stage here. I want to move stage by stage. Okay. From the roots that we obtained, or from these solutions that we just obtained here. All right. What we are going to have is that we are going to obtain the complementary function. What is this complementary function about? Okay. The complementary function, written as YC, is the one that you take from the format of the solutions that you obtained here. That is the complementary function. You take it from these solutions the way that they are given here. And what is it that we are given? All right, we are given that, all right, this is going to be our complementary function. You can write it in terms of S. You can write it in terms of Y like this. As for me, I'm just gonna, all right, oh, sorry, this was in terms of what? This was in terms of S. So I'm just gonna write in terms of S. You see now? So this is the complementary, but it was supposed to be YC like that, right? So as we're gonna use S because it's in terms of S. So SC, the complementary function, you take it from these solutions that I was showing you here, from the solutions that you obtained. These are the complementary solutions that you can have. So it depends with how the solutions are. If they are equal, you're going to write it this way. If they are not equal, you write it this way. If they are complex, like what we have here, these are complex solutions. So we are going to have our solution like this. So this is the format that we are supposed to have. So I'm going to write this format. But remember, it's no longer in terms of, it was in terms of y and x. But this one is in terms of s and t. So where there is y here, we are going to put s. Where there is x, we are going to put t. Wherever we see x, we are going to put t. Remember, it's y in terms of t this time. So that's why I'm trying to say, wherever we see a x, we put a t. All right. So meaning to say, this is how our solution is going to be like. SC is going to be, since we saw that this is these solutions here are complex. So our solution is supposed to be given as, so I'm just gonna rewrite this. It was supposed to be e to the exponent of Rx, all right? E to the exponent of Ax, which is from this part of our solution here. So it's gonna be Ax, but it's now As. We are no longer having what? We are no longer having x. So T for x, sorry for that, At, which represents our t. Okay, then we move on into A. So this is supposed to be into A, the cosine of bx. So this is the cos of bx. Remember our bx is t now, all right, plus b sine bx. So our x is now t, so it's going to be bt like this. All right, so that was the solution, and this solution was on a condition. Remember, it was on a condition where r is equal to a plus or minus ib, like this. So meaning to say, our a, we're just substituting as it is. Our a in this case from our solution, remember, from our solution here, our a, so this is our a, plus or minus ib, like this. So it means as c, which is our complementary function, is going to be e to the exponent of at, right? The complementary function first, at. So our a is what? Negative what? -2. So it's going to be negative 2t, like this. Into a, this a, it's a constant to be found. To be found. We do not have this one. We have to find it, all right? So you're gonna have cos bt. What is b? B is the part of the complex, the part of the imaginary part. And our b here is what? It's 3. So it's going to be 3t, all right? Plus b again is a constant to be found. So this is going to be sine bt. Our b, remember, is what? Is 3. So it is going to be 3t, like this. So this SC represents your complementary. In actual sense, it was supposed to be like this. Later on, you were supposed to have something like this. Y being a combination of this. If it was in terms of y, guys, take note. I want you to relate it to y, because mostly that is where we have it, and that is where we understand it much better. It is supposed to be y is equal to yc, which is of the complementary, plus yp, that is representing what? Our particular integral. So we have two things that we have to consider there. We have the complementary, then we have got the part of yp. The complementary, this one, is the one that you obtain from the solution if it was in terms of y. Here it's in terms of s, so it means s is supposed to be sc, the complementary, plus sp for the particular. All right, that is the idea there, because we are dealing with s this time, okay? But it was supposed to be like this. So this one, we are not given, we are only given for the complementary. This is the one that we are given in our formula sheet, how to expand or how to have a complementary solution. The particular, you are not given. You are the one that is supposed to figure out for the particular integral, which is determined by f of x. So the particular integral is determined from this f of t that we, remember I was saying in terms of f of x, but this time it's in terms of t. So this is where you determine it. So how do you determine? One, you have to check what that solution here represents. What is it representing? it's a quadratic expression. So for every quadratic, if it was a condition like this, let us put it in terms of x. If it was in terms of x, so it was supposed to be ax squared plus bx plus c. This is the format of what? Of a quadratic. All right, this is the format of a quadratic. To say your f of x is given in the form of a quadratic like this. So what is going to be your particular integral? It remains, or it is taken from that f of x as a quadratic as it is. All right, so you take your quadratic as it is. But now I want us to consider to say on our quadratic that we are taking, one, it's in terms of t. So it was supposed to be a t squared plus bt plus c. This is the format of our quadratic in terms of t. Number two, we have already exhausted a and b. We have already used this a and b. So meaning to say our particular integral of yp is going to continue from this part that we have ab. So it's going to continue from c. So yp is going to be given, since it's a quadratic, it's going to be a quadratic. So it's going to be, it was supposed to be cx squared, but it's in terms of t. So it's going to be ct squared plus, we move on from the constant c, we move on to the constant d. So it's going to be dt plus e. Remember the format, it was supposed to be a t squared plus bt plus, where these are constants. All right, a, b, c are constants. So they follow the order A, B, C. So already we have used A here, we have used B. So we are supposed to continue from what? From C, C, D. These are constant. They are not supposed to be the same. You cannot say you've used A, then you write also AT squared here. It's going to be wrong. All right. You continue with other, because we need to find these constants. All right. On a condition like that, we need to find what is the value of A, what is the value of B, what is the value of, you see now. So where now do you find these values of A, B, and C and this? Okay, this is what you do. From this particular integral, you are going to need, because guys, I want you to be careful. This is the particular integral, this one that we wrote in terms of the quadratic. So what we need is to come back here and form an equation where we are supposed to substitute these, replace all these, and write them in terms of t, so that we say these two equations are equal. And if they are equal, we can find other values from there. So in order for us to equate these, or in order for us to substitute, it means we must have we must have a condition where we substitute that represents the s dt. We must have a second derivative of s with respect to that is from what? From the particular, where s, so we're going to take this s representing our particular integral for that. So meaning to say we are going to need the derivatives of these that we are given in terms of t, all right, from the particular integral. So what is the derivative of y here with respect to t? The derivative of y with respect to t here, we're going to multiply this, a constant, drop the exponent, so that will be 2c t. The derivative of y with respect to t, d is a constant, remember, so it's going to be plus d. E is a constant, so it will give us a 0. All right, so this is the first derivative. We find the second, because there's a second derivative on our formula there, so we're going to find the second derivative with respect to t. So the second derivative, we differentiate with respect to t. This is going to give us what? 2c. D is a constant, so it's going to give us a 0. So here, what is it that we are simply doing? We have to substitute these correspondingly where to this derivative that we are given before, corresponding in terms. That is how you find, that is how you work with a particular solution. So we are going to substitute these as they are in place of the second. So you're just saying this is the second derivative of s with respect to t. All right. So that is how we're going to have it. So this is supposed to be s, right? So let us have s, p there. You see this thing of used to work with y. So this is sp, the derivative of s with respect to t, all right? The second derivative of s with respect to t. So this is the second derivative. So this is from the particular integral, all right? So it's good that you also have the equation. So you can also recall, okay, for any mistake, you recall, oh, no. There I'm supposed to have this. Okay, so this is what I'm trying to say. We are having s with respect to t. The second derivative of s with respect to t. Now we are substituting what is equivalent. There is what? It's 2c. So you're now forming an equation. So this is going to be 2c. We substitute. So 2c plus 4 into ds dt, the derivative of s with respect to t from our particular. You substitute from the particular integral. So this is going to be 2ct like this. So this is 2ct plus what? Plus a d, all right? Plus 13s. So it's going to be 13s. Guys, let me just expand once, guys. It's going to take us a lot of time. We've got a lot of things to do, guys, okay? So let me just substitute straightforward because, all right, the s, the t, the s, this one, the second, we said it's going to be 2c. So this is supposed to be 4 times, it multiplies your ds dt here. So this 4 here multiplies everything here. So let's just multiply 4 times 2, which is going to be 8. So that is going to be 8 ct. All right, 4 times d. So it's going to be 4d. All right, so you're multiplying by this 4. The same thing, this was supposed to be 13s. So instead of us, guys, opening bracket 13, you multiply 13 multiplies s as it is, all right? So this, let me rewrite it properly. This is 13 plus 13s as it is. So it's 13 multiplying everything on this s is going to be multiplied by what? By 13, the whole of this part here. So let us multiply 13 times this s that we had. So it's going to be 13 ct squared, 13 times d, which is going to be 13 dt, 13 times e, which is going to be 13a. Remember, this is our sp, the one that we are multiplying by what? By this 13. So this here, after substituting, it must be equal to the quadratic. Remember, we took our sp from the format of the quadratic because it's a quadratic. That's why we wrote this. If it is an exponential, you have to use an exponential. If it is a linear, we have to use the format of a linear. Cx plus d, it's a linear. But this one is a quadratic, so that is why we have to use the format of a quadratic. So we have to equate to that quadratic that we were relating to. All right, so that quadratic there is equal to what? So this whole part is equal to 39. All right, t squared, like this, plus 11t plus 54. So this is what you're going to have. So what you have done here is that you have formed an equation, but this equation that you have formed it in a way like, I want us to explain, I want us to have this is like from our N4, when we are talking about complex numbers, we had a condition like 2 plus 2j like this. Maybe I'm given something like this, 2 plus 3j like that is equal to, maybe this is x plus yj like that. Because these formats are equal, are the same, we were simply equating to say x is equal to 2, 3 is equal to y. There's no important calculation to be done there. Why? Because of the format. And this is the same thing that we have. The format that we have this side here is the same format that we have on that side. Only that here it's just it's just written anyhow. Here it's properly written. We can see our normal quadratic, but it is the same format. The highest exponent, which is of t, which is 2, we move on to t, then we move on to the constant. So if it is of that these formats are equal, are the same, and these two equations, what we have on the left-hand side is equal to what we have on the right-hand side, we are going to equate what we can from the coefficient. Let us start with t squared. T squared, the coefficient of t squared, just like that part that we had in our partial fractions, when we're dealing with partial fractions. So equating the coefficients of t squared from the left-hand side, we've got t squared. The coefficient of t squared is the number that is affecting t squared, which is the term here affecting t squared, which is what? Which is 13c. So 13c, do we still have any t squared? That is the only t squared. It must be equal to the coefficient of t squared on the right-hand side, which is the coefficient of t squared here is what? 39. Here, the number that is affecting t squared is 39. So 13c is equal to 39. So what is the value of c? We can divide by 13. By 13, this gives us c. So c is equal to 39 divided by 13. That is going to give us something like 3. So that is the value of c. So you can divide here 39 and 3 and 13 from your calculator. That will be a 3. 39 divide by 13. That will be a 3. All right, then we move on to another one. We have to find these constants. We have to find everything here. We have to find the C, we have to find the D, we have to find the E. All right. So to find the D, we can work with the constant, we can work with T, the coefficients of T. We are working with T, the coefficient, what is affecting T? The terms on T on the left-hand side, what is affecting T? On the left-hand side here, we've got T here. So the coefficient of T there is what? 8C. So it means if I combine this C, 8C to another, I move on where there's T, here there is T. The coefficient of T there is what? 13D. So plus 13D, I no longer have anything. So this must be equal to what I have on the right-hand side, the coefficient of T here, which is what? Which is 11. So this must be equal to the coefficient of T on that side, which is 11. We have formed an equation again that we can solve for D since we have the value of C here. C is 3, so it's going to be 8 times 3. 8 times 3, that's what? 24. So 24 plus 13D is equal to 11. So 13D is equal to what? Transpose 24 to the other side. That will be what? 11 minus 24. So guys, my mind is tied up. Let me just use the calculator here. 11 minus 24, like this. 11 minus 24, that will be negative 13. So this will be negative 13. So you can divide by 13 by 13. This will give us a negative 1. All right, thus we have got the value of D. If we divide by 13, this will give us a negative 1. Okay, let's move on to the other part. This is our D. So we are left with what? With E. So we can equate the constants to find E. E, we can find it where there are constants. So this time we are going to work or to equate constants. So this time you are going to equate constants. All right, so let us equate the constants. So the constants here, we are talking about where we do not have, there is no T. All right, we do not have T, like this part of 2C. We do not have C, we do not have T there. So it's 2C on the left-hand side. We also have plus 4D. Plus 4D, we take as it is, plus, sorry, we do have, here there's a T, we do also have 13A plus 13E like this. These are the constants from the left-hand side combined together. They must give us the answer that we have on the right-hand side for the constant. Then the constant that we have there is a what? It's a 54. So we have formed an equation that we are supposed to solve, but knowing that we have got the value of C, we calculated the C before. Here we got our C as 3. We calculated D before. This is minus 1. So let us just combine and see what we are going to have on these values, guys. Like I said, let me just use the calculator. My mind is just somewhat tired up. So 2 times 3 here, all right, plus, this is 4 times negative 1, 4 times negative 1, like this. So this will give us a 2. That's 13E is equal to, remember, we are supposed to have a 2 here, but we are going to transpose it to the other side. So it's going to subtract on this side because we have got a 2 there. So we're going to subtract a 2 on 54. We subtract a 2, that will be a 52. All right, so divide by 13 by 13, that will be divide by 13, our answer, that will be a 4. So E is going to give us what? A 4. So guys, I didn't even show the screen here. I'm just showing this, guys. All right, here. I was saying this was going to give us a 2. So you take it to the other side. This will be a 54 minus a 2, which will be 52. Then we divide by a 13. It gives us what? A 4. So this is the value of what? Of E that we are going to get, which is what? A 4. So these are the questions that's how you might be given. So now we are going to substitute so that we have our solution properly written. All right, so let us go back. Where is that particular integral? Here. So remember our particular integral SP here is supposed to be, it was CT squared. Let me rewrite it down. Our particular integral, it was this was in terms of S. So we say this is SP. So it was SP is equal to, remember it was given as CT squared plus DT plus E. So now we have calculated the values. So we're going to substitute. So meaning to say our particular integral is going to be C, our C, which is given as what? As 3. So this will be 3 T squared. D, which is -1, -1 times T, which is negative T. E, which is a 4. So this is what we have. Okay. So what was the purpose, or why are we finding this particular integral? Okay. Like I said before, we are supposed to have a combination now of both. If it was in terms of y was supposed to be the complementary plus the particular. But this one is in terms of what? It's in terms of S. So it means S, which is our solution at the end, S is supposed to be SC, which is the complementary that we got, plus the particular integral that we have. So it is going to be a combination of these two, all right? Since it is in terms of S, so we're going to have it this way. So let us substitute. We have SC, the complementary function here. Where is that complementary function? Here, we calculated this here, if we still remember. That is where we had our complementary here, there. So we are going to substitute this as it is, our complementary function as it is. E to the exponent of minus st as it is. So take note of how you are working, guys. Every information, you have it. You have the information there, all right? So the information is there. So you just have to be careful on whatever that you attempt on how to attempt, all right? So let me take my essay and also take the other solutions together to combine, all right? Let me do this, guys. So I'm just gonna rewrite this. I hope you see our answer, guys, because here there's a lot of things that we have written here. All right, so here we said we're gonna have this as S is equal to the complementary. Remember, it gave us e to the exponent of minus 2t. It was e to the exponent of minus 2t into a cos, that was a cos 3t plus b sine 3t again. All right, it was b sine 3t like that, okay? Then we add the particular now. So we're gonna have our particular integral, which is yp. Now it's SP, okay? I'm still having y in mind. This is our SP, the one that we got here. Remember our SP, we have it here. So you're gonna combine plus, SP gave us what we are combining as it is, all right? So this is gonna be plus our SP as it is. So this will be 3t squared minus t plus a 4 like this, all right? So this is where we are. Now the question is that we were supposed to leave our answer like this. I want you to be very, very careful there. We were supposed to leave our answer like this. We're supposed to leave it like this. But now take note. They gave us what we did here, if it was for general solution, you were supposed to you just leave it like that. You find your the particular integral, whether it's given to say the question is saying find the particular solution. The particular integral, you have to find A, B, C, D, and E. Those solutions, if it was, you have to find them. But these ones, the A and the B on the complement, these ones, on our complementary function, the a and the b, these values here, these letters here. In order for us to find these, we have to use the information that there we only have to apply the original information that we are given. And what is that original information that we are given? We have to go back now to this information when t is equal to. So I'm going to explain this in you understand me. Okay, let me put it this way. This information here that we are given, that is the information now that you are going to take into consideration now to find what? To find your particular solution. This whole part was not for the particular solution. This whole part that we had, it was for the general solution. All right, let's get back to where we are here. This whole part here that we're doing, if the question was to determine the general, that is what we are supposed to do. Okay? That is what we are supposed to do. So this is our general solution here. All right, this is too big, guys. I'm going to reduce. I hope we are together here now. This is where we are on this general solution. So this is what I'm saying. Be careful here. Let me explain before I explain this part here. Okay. Here, on this part here. These values that we calculated for C, D, and E, do not confuse them. These values, they were for the particular integral. And for each and every case, you are supposed to find them. Whether the question is for the particular integral, for the particular solution or for the general solution, you are supposed to determine these ones. It's a default you're supposed to have. And these are the stages that you're supposed to do because you have to substitute them back to the original equation. So you find that SP, you find its derivative, its second derivative. You substitute to that original, like the differential equation that you're given, equating to that expression, depending with what you're given. Is it quadratic? Is it linear? Is it an exponential? Each and every part has got its format. All right. Now that you have got this is what I'm explaining to say these values that we calculated, it was D, E, and it was C, D, and E, this one that we substitute. It does not mark to say we have the particular solution, no. Do not confuse this. This is a particular integral, not the solution. To have the particular solution, we are now at this stage where we are supposed to find A and B. So where do we find them? From the information that we are given, that one on top. Remember, the information states that, I'm going to rewrite it here. We were given that when t is equal to 0, when t is equal to 0, s is equal to 1. All right. And also, the s dt, the derivative of s with respect to t, is equal to 8 when t is equal to 0, when t is equal to. So here, what are they trying to say? They gave us information where we see a t, we are going to substitute as 0. At that moment, s must be equal to 1. Are we together there? Where there is a t as a 0, s must be equal. That is the first condition. All right, let's substitute. Where there's s, we're going to substitute a 1. So 1 is equal to, all right, here t is a 0, so you know that e to the exponent of and 0, it's a 1. Any number to the exponent of it is what? It's a 1. So we are going to substitute wherever there's a t, we are substituting what? A 0, remember? So there we're going to substitute a 0, and here we're going to substitute a 0. So what happens on cos 0, it's a 1, remember? Cos 0, let us save our calculator here. Cos 0 is a 1. It's different from sine. Cos 0 is a 1. So if you multiply that by a, we're going to remain with a. So you're going to have 1 here. Then this is going to be a. But for sine, now what happens is that sine 0, that's a 0. All right? Sine 0 like this. Sine 0 is a 0. Sine 0 like this, that's a 0. So when you say here, there's nothing because you're going to multiply 0 times b, we do not have anything. So it was just going to be a. All right? So this bracket here, we are just going to remain with a. Remember, we said cos 0 gave us what? Gave us 1. Then 1 times a, which is a. But this e to the exponent of 0, which is outside of the bracket, it gave us a 1. All right, plus here we've got t as a 0. So that is 0 there, minus 0, then we're going to remain with a 4. So we are going to remain with a 4. Remember, guys, t is a 0, so 0 squared, that's a 0, minus a 0 there, so we're going to remain with a 4. So that's plus a 4. So here we can calculate the value of a. So as you can see, a is straightforward. 1 times a is a. So we're going to have 4 to the other side. 1 minus 4, which is minus 3, is equal to a. So a is equal to what? Minus 3. Okay, so we have the value of a, which is minus 3. What about the value of b? A was straightforward, but b now we have to move on. They are giving us another information. If we differentiate s with respect to t, all right, it must be equal to 0. The derivative of s with respect to t must be equal to 8, I mean, where t is equal to 0. The derivative of s with respect to t. So the question is, where are we going to have the derivative of s with respect to t? It means, guys, we have to differentiate. This is our s. All right, so let us write. Remember, we've got our a this time. So I'm just going to write my a here. All right. So we got a here. Remember, our a, we got this as minus 3. I'm just going to use this space here. So here it means that the s dt differentiate s with respect to t. That's the s dt. So the s dt, we're going to differentiate this part with respect to t. So let's differentiate. All right, the first part here, we have got a product. We could have expanded, then differentiate, but no problem. Let us do this aside. Let us differentiate here. All right, so I'm gonna do this, guys. Remember our product rule. All right, so I'm gonna do this. All right, this is our u, this is our v. So I'm taking v as the wall of the bracket here, the wall of this bracket as it is, as our v. Okay, I'm taking this as it is, the wall of this as it is. So this is what is going to happen. We're going to take our formula for the product. All right, it's either you can expand, then you work a product different, because there will be a product here and another product for sign, or you take it as it is, this out and this as a single fraction. You understand me? No problem. So our formula is going to be u by v. All right, u by the first derivative there of v plus, then we're going to have, in this case, v u like this. All right, so u, it means we're going to take our u as it is. So this is e to the exponent of minus 2t. The first derivative of v, which is what is inside of the bracket. So if we differentiate here inside of the bracket, this multiplies here, so it's going to be minus 3. Remember, of course, it gives us a sign. So it's minus 3a sine 3t. All right, we differentiate here in place of sine changes to cos. So it's going to be plus 3 times b, which is 3b cos. Remember, sine changes to cos, so it's going to be cos 3t. So this is what we have a, that is u times the first derivative, all right, plus v. This time we're taking the bracket as it is for v. So this is our bracket, a cos 3t plus b sine 3t as it is times the first derivative of what? Of u. This is our u. If we differentiate e, remember we drop the exponent, this negative 2. So it's going to be negative 2 e to the exponent of minus 2t. All right, so let us just put it this way, like this. Okay, that's a single term. So we have differentiated this u. But remember, our purpose is to differentiate everything. This was for this part here alone. All right, this part here alone. That is where we apply the product. But we still have terms to be considered here. 3t squared, we have to differentiate that 3t squared, but by just looking here, still if you substitute t, it's a 0, it's going to be a 0, no problem, but it's going to be 6t. Differentiate this, is going to be minus 1 on t. Differentiate for a constant, it gives us a 0. All right, so this is what we are having in actual sense, like after everything, like the derivative that we are having in this case. All right. All right. So now let us substitute, guys, and see what we're gonna get here. I want us to see what we're gonna have. All right, no problem. No problem. Remember, our A is, we have the value of A already. Let us substitute, guys, no problem. Wherever there's a T, gonna substitute a 0 there. All right, so that's a 0 here. Okay, then the SDT, which is 8, the SDT, that is 8 here. So 8 is equal to, if we substitute a 0 here, this one, it'll be a 1. All right, a 0 here. Remember, I said sine gives us a 0 totally. So this one is already out. But cos, if we substitute a 0, cos gives us a 1. So it's going to be 3b here. So you're going to left with 3b times 1. That will be 3b times 1, which is 3b, times this one is just going to be 3b like that. All right, so this will be 3b. Okay, let us move on here. If we substitute our t being equal to, remember the condition there is, maybe I minimized a lot. Okay, here the condition is that t must be equal to 0. So here, if we remember cos, we substitute before, guys, we said cos gives us a 1, so this will be a 1. Sine gives us a 0 totally. Then here e to the exponent of a 0 gives us a 1, so meaning to say we're going to get a 1 here, but that 1 is going to multiply with minus 2. All right, so meaning to say the a that we got here, remember we said a plus a 0 is what? It's a. Then this a times the minus 2, because this one, it gave us a 1. E to the exponent of 0 is what? It's a 1. So it's a times minus 2, which is what? Minus 2a. So this will be minus 2a. Then here, 60, a 0 there. We are left with what? We are left with minus 1. All right, do we have another term? No, this is what we have. So we have formed an equation, but knowing that a is equal to what? A is equal to minus 3. We calculated a before, so we are going to substitute a, which is minus 3 here. Let us substitute our a. So that means if we substitute minus 3 here, it means we are going to have 8 is equal to 3b. All right, minus 3 minus, that's a positive, so it's 6 minus 1, which is 5. Is that so? Let us just use the calculator, guys. Now I said my mind is now tired up. Like minus 2 like this. No, it's minus 2 first. Open bracket 3, minus 3 there. All right, then minus 1 like this. So this will be 5. So you're going to have a positive 5 here. Then transpose to the other side is going to be a negative. So that will be 3. 8 minus 5 is 3. So 3 is equal to 3b. So meaning to say b is equal to 1. So therefore b there is going to be 1 if we divide properly. So this is what we have. Remember, it was now finding of the particular solution. That is the part that made us to find A and B. But here we already had the solution, but it was what? It was the general solution, this one, where S is equal to this and that here up to this. I said this is what we call the general solution. Your general solution. Okay. So now, to determine the particular solution, we have to substitute A and B because we calculated this A and B. So therefore, our S is going to be given as e to the exponent of minus 2t into A. Our A, we calculated there. Our A, remember, on top, we said our A is what? Negative 3. So it's going to be negative 3 cos, or you can even start with the sign, or you can even start with the cos, no problem. Negative 3 cos 3t plus a b. B is a 1, so this b is a 1, so it's going to be plus 1 sine 3t. Plus 1 sine 3t here. The rest remains as it is. There's nothing that you're going to substitute there. We do not have a, b there, so it's going to remain as it is. 3t squared minus t plus what? Plus a 4, like that. So this is what we are going to have at the end. So that's how you work out your particular solution now. It's a solution this time. We have to find the values of A and B. So I don't know, guys, it's up to you. But as you can see, it's an interesting type of a question. Do not be confused where to substitute and this and that. So just hope we're gonna have more questions. At least if we can have maybe 2-3 questions of this nature. Also be able to be part of the members. So I do not know if this video is going to be for the members, but if this video is for the others, then make sure that you join membership, because on membership, we are going to have unlimited access of questions and question papers from our past exam papers in preparation of exams. So make sure that you become part of the membership for N6 studies, not just any membership, but make sure you join for N6 studies. All right, these were the solutions, guys. I just hope we understand. We're just gonna try by all means to work with more questions. All right, just hope we understand. Okay, particular integral, complementary function combined together, they give you y. After finding that y, you've used the conditions, because after having this s here, a general solution, if we're not given that s is equal, we are supposed to be done here. But now they gave us those conditions, s is equal, you have to use those conditions accordingly. All right, so you have to use those conditions accordingly. So we shall just work with more questions. I hope now we can see everything here. Just hoping for you to see everything like this. Is it possible? Yeah, or maybe a little bit. Okay, like this. So from the general, I want you to see from the general solution there. All right, like this. So the first step is for you to just substitute so that you calculate your A. Where was that calculation of A? All right, here. You substitute everything as it is given from this information. But now they say we need the derivative of s. So you have to differentiate that. So you find, if it was dy dx, that is for y and x. You have to find it like that, all right? So you can find, depending what you're given. This was for s and t. And also do not, you see that confusion of y and t and y and x, s and t. So you must be careful, s, ds, dt. So your equation is supposed to be s with respect to t. Y with respect to x, your equation is supposed to be y is equal. These functions here were supposed to be written in terms of x. If it was for y and x, we're supposed to have this as y is equal to. That is the only difference that you have. So with this question, you can answer a question that has got a y dy dx. Using same idea, you will see that you obtain the answers correct. But if there's a question that still have a challenge, let me know about that differential equation so that we can work that question. But to have access of asking your questions, join membership.